In this video, we're going to look at some exam questions as they appear in the IEB Further Studies program, specifically looking at the areas of sectors and the length of arcs. Now for this section, you will need to remember the following. First of all, you must always work in radian measure for your Further Studies paper. And secondly, you will need to recognize the formula. Now these two formulas do appear on your formula sheet, but the first one is for your arc length. So your arc length is equal to r times theta, where r is the radius and theta is the angle. And the area of the sector is going to be a half r squared theta, again where r is the radius of the circle and theta is the specific angle that you're going to use. And the other three things that you will need to remember come out of your core math syllabus, and that is the cos rule, the sine rule, and the area rule. So just be aware of those as well, but they also do appear on your formula sheet. So let's just have a look at a few examples. The first one we're going to look at came out of the IEB exam of 2020. The sketch below is a circular field with a center pivot irrigation system on it, where O is the center and OCB is a straight line. OA is 60 meters, OC is 50 meters, AC is 70 meters, and an aerial photo of the field shows that the shaded area is infected with weeds, and we want to know what percentage of the field is infected. So the first thing we need to do is calculate the area of the shaded region. Now to calculate the area of the shaded region, we will need the area of a sector, and we're going to subtract the area of the triangle, and that will leave us with the shaded region. So let's first look at the area of the sector. But before we do that, we need the angle theta. Now to calculate theta, I've got three other measurements in that triangle. I've got 60 meters, 50 meters, and 70 meters. So if I have all three sides to a triangle, I can use the cos rule to find one of the angles. So we're going to use the cos rule, and remember the side that lies opposite the angle that you want is the one that's going to stand on its own in the front. So 70 squared is equal to 60 squared plus 50 squared minus 2 times 60 times 50 cos theta. So if I want to calculate theta, I'm going to get cos theta on the left-hand side and everything else to the right. And it's not necessary to calculate that fraction first. Remember, you can just go cos minus 1 of that fraction, and you end up with theta is equal to 1,369. I've rounded off to 3 decimal places. You will follow the instruction on the paper, but remember the instruction on the paper generally refers to the final answer, so try and keep the decimals earlier on as long as possible. So 3 decimals would be reasonable to work with. Now that we've got angle theta, we can calculate the area of the sector. Now the area of the sector, remember, is a half times the radius squared times the angle, and the radius of the circle is 60. Then from that, we're going to subtract the area of the triangle. Now the area of the triangle in this question, it's going to be safest to use the area rule, which is going to be a half of 2 sides multiplied together, multiplied by sine of the angle between those 2 sides. So we get that the shaded area is 995,295. But we want to know what percentage of the field is infected. So we need to know the area of the full field as well. Now the area of the full field is a full circle, so pi r squared. So the percentage that's infected would be the 995 with decimals over pi r squared. So we can calculate that the area of weeds on this field is 8,8%. Now IEB 2016 has a very similar question, so it would be a good question to try after this one. The next one is a question that's been adapted from the IEB 2010 paper, where you are given a window, and the window is made up of a rectangle with an arched top. And we first need to calculate the value of theta. Now to calculate the value of theta, again, I'm going to use a triangle where I have 3 sides to it. Right, so to calculate the angle of theta, we're going to use the cos rule. And remember, the side opposite the angle that you want is the side that stands alone on the left-hand side. So it will be 2 squared is equal to 2.7 squared plus 2.7 squared minus 2 times 2.7 squared cos theta. So isolate cos theta on one side and go cos minus 1 of your fraction, and you end up with theta is equal to 0,76. I've chosen to round off to 2 decimal places, following the instruction given on the paper. The second part of the question is to calculate the area of the window. Now the window is made up of a rectangle plus an extra little portion at the top. So first of all, the rectangle is nice and easy. The dimensions of the rectangle are just 3 times 2, so that purple rectangle is going to be 6 meters squared. And now I want to calculate the area of that little piece at the top. Now to calculate the area of the little piece at the top, it's quite similar to the previous question, where we have a full sector minus a triangle. All right, so we've got the full sector on the top minus the triangle at the bottom, which means the area of that little piece at the top is 0,2590. So if I want the area of the full window, we're just going to add the rectangle with a little shaded piece at the top, and we end up with 6,26 meters, rounded off to 2 decimal places. Question is to determine the perimeter of the window to the nearest whole number. Now this question didn't appear in IEB 2010, but we have enough information, so we're just going to calculate it so we can practice working with the perimeter or the length of an arc as well. So if we want the perimeter of the window, we've got the length of an arc at the top, and then we've got a rectangle at the bottom. So the arc is just going to be r times theta. Now remember, we've got that theta is equal to 0,76 from the first question, and the radius of that circle is just 2,7. So the length of that arc is 2,052, and the other measurements that we need are 2 sides of 3 meters plus a side of 2 meters. If I just add them together, I can get that the perimeter of the window, correct to the nearest whole number, would be 10 meters. So that was just a little extra question that was added so that we can work out the length of an arc. 2008 had a very, very similar question, so it would be a good question to try after this one. In 2013, they asked us a question where we need the area or the volume of water in a pipe. So you're given a cylindrical pipe with a diameter of 10 centimeters, and the pipe has a length of 50 centimeters, and it's lying on its side with water, as shown in the diagram. First of all, we want to show that the width of the surface of the water is 8 centimeters. Now that's relatively easy. We're going to use our Euclidean geometry basically from core maths, and we've got that the radius of that pipe, because the diameter is 10 centimeters, the radius is 5. And then we know that the depth of the water is 2 centimeters, which means that I'm left with 3 centimeters to the center of the pipe to give me a total of 5. So if I use Pythagoras to calculate that little third side of the triangle, we see that the third side of the triangle is 4. We can use our Pythagorean triples, which means that AB is 8 centimeters. Now we need to look at question B, which is determine the water of the volume in the pipe. Right, again, the volume is going to be made up of a sector minus my triangle. Now, before I can do that, I need to work out that angle theta in the middle. But again, I have 3 sides to the triangle because I've got 5 and I've got 8, and my other OA will also be 5 because it's the radius. So again, we can use the cos rule to work out angle theta. And the side opposite the angle I want must stand alone on the left-hand side. So we end up with cos theta is 5 squared plus 5 squared minus 8 squared over 2 times 5 times 5. And using cos minus 1, we can end up with an angle of 1,855. So now we need to work out the area of that bottom arc. So again, it's the area of a sector minus the area of a triangle. Now the area of the triangle, you can use the area rule, but because we've got the perpendicular height as 3, we can use that as well. So just a half base times height, but the area rule will work just as well. So we end up with the area of that little piece at the bottom is 11,1875. And remember, I'm keeping as many decimals as possible so that I round off in my final answer. Now we want the volume of the water in the pipe, so the only extra thing we need to realize is that length of that pipe is 50 centimeters. So volume is just the area of the base times its length. So I get a volume of 559,375 centimeters cubed. And the IB paper from 2019 has a similar question but slightly more difficult, so it would be a good question to try at this time. So you hope you notice that the questions in this section are always very, very similar. They often require you to calculate theta, and cos rule is usually the best for that. Then they require you to work out the area of a sector and the area of a triangle and subtract them. So the questions, although the pictures always look quite different, the method is usually very, very similar. Thanks for watching Max Maths. If you liked what you saw, please like, share, and subscribe.